So the mean is 150.8 and the standard deviation is 8.8.
Awesome!
So to find, we use the app thing, put in the z-score and get the proportion, which is 0.5.
Wait,
0.0533. Woo!
Okay, now we're finding if a student scores in the 10th percentile, what would their corresponding z-score be?
Okay. How do we get to that? Okay. So click that area. Okay, so we want to go back up to the app and just type in 0.01. That'll be 10%.
The area?
What?
In the area?
I think. Possibly.
Yeah, because the area was the percentile, right?
So the 25th percentile is the number in a data set that is greater than or equal to 25% of all the values. So the 10th percentile would be that area.
Okay. So then the answer is 2.326.
2.326.
Yes.
2.
Wait, is it in both 10th percentiles or just
the 10th?
Well, both of these would be 10 percentiles.
Be the same thing, though, right?
Yes.
Well,
Is that changing?
It would be 2.326 or negative 2.326 and 2.326. So.
But if you change that, then if you look back up at the area, it says 0.02.
You change what?
Select both 10
Let me-
percentiles and then put in the area.
Let me check again.
Oh.
But let me check.
That makes sense. Because, yeah, that was still 0.0 or 0.010.
Oh, wait. Click on the areas that are left of the positive z-score shaded blue. That would be the 90th. So
2.576?
I think we were right the first time. I think it's...
So this is the 10th percentile.
Yeah.
This is the 90th percentile. So yeah, it's negative 2.326.
Why is it negative?
Because on this side of it, that's the 10th percentile, and over here, the small one, that's the 90th percentile. Yeah? No?
So?
Don't you, in scores like that, don't you want to get in the smaller percentile because that means there's less people that scored there? Scored.
No, because if it's 10, that means... wait a sec. Where is that? 3060. No, okay. Because when it's 10, that means you scored 10% better than everybody else. Or you scored better than 10% of the people. So the higher the number you are, so like if you were in the 96th percentile, then you scored better than 96% of the people.
Oh.
Okay. So
I believe so.
the way you said it sounds right, but let me see here.
Because if you look down in the book on 2.4,
Yeah.
it says the 90th percentile, and see how it like covers the middle and the last part.
2.4, 90th percentile. Okay, yes.
So that would all equal 90.
It's negative. Got it. Okay, so if you're in the 10th percentile, then you scored better than 10% of the people.
Yeah, so it was like negative
Right? That's how you say it. That's how you said it.
I think so.
2.3.
Then if you're in the 90th percentile, then you scored better than 90% of the people.
Yes.
Okay.
What is the quantitative GRE score for a student who scores in the 10th percentile?
Okay.
Anyone? Come on.
We have a standard deviation, right?
Okay.
So,
8.8.
so we have our number was negative 2.326 equals x minus the mean, which is 150.8 over 8.8. Times both sides by 8.8. And 20.4688 plus 150.8.
You did minus. Did you mean to do plus?
That's what I meant. Beautiful, that's a positive number.
130.33. Don't ask me how we got that because I don't know.
Alright, do you want me to explain how I got that?
Yes, please.
Alright, so we have the original equation of your z-score equals x minus the mean
Yes.
over the standard deviation.
Okay.
There we go. So I just plugged in numbers. So we said the z-score was negative 2.326,
Yes.
and that equals to x minus our mean, which was 150.8, and had that over 8.8, which was our standard deviation.
So it's just a matter of plugging in numbers.
Okay. So z equals x. Hold on. I know where that is. Let me find it. Z. Z equals x minus the mean over the standard deviation.
Mm-hmm.
Okay.
Alright, number 7.
Hold on. Okay, so the x is what? Because that one confused me.
That's what we're solving for. We're solving for x.
Oh.
So in this equation, x is whatever your value is that you're using. So x would be, let's say we're back at b.
Uh-huh.
So our x was 165.
Okay.
So
when
now
you're
we're trying to find that number.
when you're putting it in the equation, though, how did you put x equals?
Okay. I'm going to write out my equation, maybe backwards. Nope. Okay. So, I'm sorry, this is all going to be backwards for you,
Okay.
but minus nothing is. I can't remember what it's called. Okay, so our z-score was negative 2.326 plus x minus. We're going to get that equal to negative 20.468. What did I write down? 1, 2. Alright.
Right there. Stay. Okay.
So I multiplied both sides by 8.8 to get rid of that on the bottom.
Okay.
And then I just added 150.8.
You're so smart. Okay. Yeah, because I knew you had to set. Yeah, you had to get x off of that.
Yeah.
Off of that fraction. Out of that fraction. Okay. So it was. Got it. Okay.
Oh, okay. Whoa, hello. Okay. Are we good?
Yeah.
All right. Number
So-
7.
The mean equals 1.8 meters per second
I can't reach it anymore.
with the standard deviation equals 600 meters per second. All right. So again, we have our mean, which is 1,800 meters per second,
Uh-huh.
and our standard deviation of 600 meters per second.
Yes.
What is the probability that a randomly selected particle has a speed over 25 miles per second? Meters per second.
Meters per second.
Meters per miles. That's really fast.
Okay. Probability.
So is this just another question that's almost exactly the same?
Mm-hmm. So. Just a second. Yeah.
Okay.
Okay.
So, how do we do it up here?
Oh, this is the same thing we did earlier. So,
Just the applet.
isn't it just the same equation we've been using?
Yeah.
Then we put in the z-score, yeah.
Yeah.
2500 minus 1800 divided by 600 1.67. Alright, so it's going to be 1.67. I don't know if your calculator's being functional.
Yeah. 1.67 for the z-score.
Yeah.
That's 0.048.
And we want it above that, right?
Huh?
We just want everything above that, right?
What is the probability that yeah. Do you want to have the blue to be above your z-score?
Mm-hmm. Okay.
Okay. Now just switch it to the other one and you have the next
So less
answer.
than.
So the next one is 0.9525.
Because I just shaded the other two areas. Not that.
Are you talking about C?
Yeah.
Or I'm sorry, yeah, C?
Yeah.
Hold on. 0.048, and then take that away. 0.953.
Yeah.
Less than 5. So do the same thing with 5. 1500.
0.953. Okay. What is the probability that a randomly selected particle has a speed that is less than.
Oh.
That's just finding the z-score again, right?
What?
So this next one, what is the probability that a randomly selected particle has a speed that is less than 15 meters per second, 1500 meters per second?
Hmm. Nope. I did not do that. So this one's pretty easy to do without a calculator.
So then you go put in
I got 0.308.
Mm-hmm.
put in this one.
Yeah.
Or 0.3085, so it would be 3.09.
3.09.
So
Or
then you're supposed to find
0.309.
between this
Sorry.
and the other one. So do you just put in this and the other one,
Just
and then go between?
no, because this is just gonna change. Oh, just change that.
How
So,
can you make it between?
things down here. Alright, so we have to do Z1, Z2. Then we have to find the difference. Z. In the area between, take Z. Let's subtract the smaller area from the larger. So we have. Um,
1.22.
Put in.
and this is between. Okay, so we want what's above this. That's just the z-score for what's below point or below 1500. Sorry. Okay.
2.
Okay. So we need to come back here and look at negative. Here's negative again. We want to find everything above it. So the area above point. 5. And then
I thought you were trying to find between.
I know, but we want that was just everything below. We want between.
So we're subtracting the larger from the smaller, right?
Yes.
So it's just 0.953 minus 0.309, right?
No, because the 0.309 is anything below 1500. So we need to find everything above 1500.
Okay.
I circled the man.
Wow.
So this is
The circle.
9525 minus.
Okay, I left the door.
691.
Negative point.
No, I was just being white because I know it's gonna be fun.
This is the square.
If you look at the sample though, for the heights of Ghanaian women.
Mm-hmm.
You're just taking the z-scores, finding the area, and then subtracting the larger number from the smaller number.
Yeah.
Yeah.
But what we did earlier, we found everything that was slower than 1500. And they want what's above 1500 but below.
2500.
Yeah.
So we just had to find the other number for 1500. So instead of whatever was less than, just click the other two sides of the graph and get rid of the less than. I think it's 13,059. This is your third quartile.
So did you get 0.261?
I got 0.2059. Oh, no, sorry. Yeah, I got 0.261, and then if you plugged it in, 0.2059.
What do you mean if you plugged it in? Plug it in where?
The app?
In the area section?
Yeah.
No, because that's what we're finding.
Yeah. So you plug in the z-score, which we just found, the 2.61, and plug it into the bottom part of the graph. On the
That's
top.
not a z-score, though.
What?
Is it? It's not a z-score.
Yeah, we just subtracted two z-scores.
Still a z-score.
No. You subtracted two areas.
Oh, man. That's
The
good.
953 and the 692 are both areas. You find the z-scores of each one, you plug them in, get the areas, then subtract the larger number from each area to find what's in between the two.
Right. Okay. Okay, so we have... equals 100. What is our standard deviation? Not 1800. Oh wait, we already got that. Okay, so -0.5 and 0.30. No. What was that? Okay. So minus -0.5. Oh, never mind. 1.667. Alright. I believe it is 0.9045. Because you'll get a z-score. Because it's what we solved earlier, so the z-score of 1500 would be -0.5, and the z-score of 2500 would be 1.167. So then you just subtract those, and that equals 1.667. Plug that in, find the area between.
What number did you get?
0.9045.
That's not what the answer key has.
Oh, what are the answer key has? Oh.
0.569. They have the area for the 2500 being 0.878.
0.878?
Uh-huh.
How did they get that? Oh, never mind. Wait. So the area. So the problem. Are you saying B is?
My parents.
Where's the answer?
This is from Home Depot.
It is.
Yes.
Where's that? Oh, I didn't. Okay, you're right. Look at you being smart.
I try. Sometimes.
Okay.
Okay, so,
Okay. How did you get that?
8783. What did we have? 9. Okay, so we must have put the numbers in wrong. So, start over. 2500 minus 1800. 2500 minus 1800 divided by 600. Okay.
Okay, that's what I got.
1.167.
All right. So if we plug that in,
1.167.
0.048. 448. One. Oh. Wait a sec. Okay. I know what I did wrong. First time I wrote this down. Oh, go away. I put 1.667 instead of 1.1667. So, come back to you. Okay. 1.166. No.
Okay, so the area we get is 0.1216, which is what they have basically. They have 0.1217, so it's almost the same thing. You round it up to the third decimal point.
Okay.
Okay, so it says P to the X is greater than 2500 equals P to the Z greater than 1.1667 equals 0.878. So we missed a step somewhere. I'm pretty sure that's what happened.
Okay, so we just subtract the areas, right? So, that doesn't make any sense. Pretty sure that's wrong.
Oh! Hey, guess what? So we take the area and we put 1 minus the area. And that gives us the 0.878, which is what he's looking for.
Wait. Okay. Okay. Wait, that doesn't make any sense.
Okay, so for B, we got 1.1667, or 1.166.
Oh, okay.
Okay, so for C, we're looking for the less than. So we put that in and get the area, and then subtract the area from 1, and that gives us what's less than 2,500,
Okay.
which is the 0.8783.
Come in.
Does that make sense?
Come in.
Because for C, we're getting the less than.
No. I don't know if she's coming home tonight. She might be at work, or because she works all six and she might be doing stuff with her friends or family. For project or group meeting for one of our classes.
Did you hit your head? It's okay. You're okay. He hit his head, that's all. Go show Daddy what you were doing. Go show Daddy what you were doing. Go.
I can't read the bosa.
¿Qué cosa?
The pen.
The only thing that doesn't make any sense to me about his answer
Uh-huh.
that so he's showing, oh, where'd it go? He says that the question's like saying what is between 1,500 and 2,500.
Yeah.
Yeah. Okay. But right now he's saying that he says that P of X, or that X is greater than 1,500 and less than 2,500. But when we found the 0.3085, that's the speed, or that's a particle that has a speed less than 1,500.
When we found the what?
So on D, we found any particle that had the speed less than 1,500.
Right.
So, what do we want to find? Something that's greater than 1,500, but less than 2,500?
Oops.
Which is why I don't understand why we use negative, or why we use 0.3085.
0.05. Hold on.
I don't know, we can just keep going, because this is the answer he has. No, computer, what is going on?
That's true. Because you think you would want to get what's above, so the 0, so you would use the 0.6915
Yeah.
for
But
the 1,500 instead of you would use what's greater than 1,500 instead of what's less than 1,500.
that's what you would think. Maybe we should email it. Or put it on the question board, make it public.
Make it public.
I'll ask him later. Alright. What is the third quartile? Wait, how did we figure this out earlier? Remember we did the 10th percentile, which is...
The third quartile, 75%.
Right. So we just plug in 75, right?
0.569.
Oh.
So it'd be 0.75.
Okay. What is the third quartile of the speed of hydrogen at room temperature? Does the
So,
0.674.
no, that's not the answer.
No!
do we have to use the SPS?
Not yet.
Huh?
Said not yet.
Why?
We're on F.
Yeah.
So what you have to do is you go back to the probability applet, and then you just plug in 0.75, because
That's the area.
in the book it says that whatever percentile you are, that's going to be...
Oh, those graphs below have nothing to do with the question.
Oh, no. So, we
It's all
have...
squished together like it was part of it. Okay. So then we just go back to the... Okay. So,
I got a football.
good job. 0.75? No, I'm sorry. Yeah, 0.75 or 0.25?
Like this.
0.75 is the area.
Okay.
Oh.
Let's not do that.
You want this go?
Is it the 0.2502? Is that what you got?
No, because you want everything below
Okay, hold on. I did
0.674.
Boom.
So 0.674.
Yes, ma'am.
0.674. Got it.
I think it's 0.4.
What'd you get? Close enough.
Okay. During your group presentation meeting, you will determine whether the data represented in these QQ plots are normally distributed or not. Record your answers for each graph. Justify your answer. Can you just say yes or no? Okay, let's see here. Scrolling down.
Oh. Right.
Oh, no.
All right. Just one moment.
No.
What?
We have to log into
We
the
have to
other...
go to the other desktop.
Okay, I can't drink any more of this stuff.
Yeah, don't do it. How about you have me open it?
Okay.
Because I've got nothing going on.
What? You don't like my 40 windows open?
No, it's getting kind of confusing.
Yeah, there you go.
Connect. Contact. Now I need to go to Island, right?
Mm-hmm.
Okay. Although okay.
Sit down.
You can do it.
You have to be quiet.
Okay. Look, my God, my papa. We watch games on the playbook.
No.
It's time magic.
Windows. Windows. No. This is like Microsoft 7.
Mommy.
Ian, don't do that.
27.
You wanna go out?
No.
Yeah, okay.
It's my papa.
Okay.
Grandma.
Furniture. What's furniture?
In my face.
Okay, trying to load it up. There we go. Something's happening.
The internet on this new desktop doesn't work very well. Whoa. That was.
Good. Like a roller pony.
Is there a link?
Oh, okay. Okay, I think I understand.
What?
Okay. So, on the graphs, there's a, what's it called? There's some line, I can't remember what it's called, but it measures,
That's enough.
what's it called?
That's enough for me.
I can't think of what it's called. But it like measures the diagonal slope, and when things vary too far from the slope, you can say things are normal distributed. So like if you look in the book, part 3.1.
Okay. 3.1.
Yeah.
Yeah, I'm there. We're looking at the
Okay,
graph.
so you look at the first graph and see how it has a constant or consistent slope.
Yes.
All right, so if we plotted, I can't remember what it's called. It's some sort of line. You would have the line go straight through, and you'll see no deviation from the line or no significant deviation, which means it's a normal distribution. So if you look at like all the plots, on the homework,
Yeah.
or the preparation, so like plot A, if you were to put a line from the first point to the last point,
Uh-huh.
how would you say that was skewed? Would you say that, or distributed? Would you say it's normally distributed, or was it skewed a certain direction?
Skewed to the left, wouldn't it be?
Mm-hmm. 2 seconds. Skewed. Right, because the tail's left.
Yeah.
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 And then same for
That's a good catch.
well no, B would
Wahoo! That's a shot.
well if we did a line from the first point to the last point on B, it would still be that same diagonal line, but I guess it's starting to if you don't do a point, it looks like a bell curve by itself.
It does, but this graph here shouldn't look like a bell curve, I don't think.
For B?
So like when you plot out the graph, it shouldn't look like a histogram. Maybe, I don't know. Just a sec. Yeah, because this is
Okay.
just plotting the points on a line. If you actually plotted this out on a graph, like, let's say, just for fun, I'm going to see if this works. Okay, so let's say I take this format. Let me take this from. Man, okay, he probably did this on Excel and then brought it over. So like if we took this and made it into a histogram, which is like a bar graph, then it would be charted. Like if you go back to the batting averages,
Yeah.
so there's a bell graph, and that would say, okay, this is a it's slightly, I don't know how to describe it. So like these are all the points that it would be on a bar graph where you say, okay, at 240.
I think we're overcomplicating this. I think. Because it's just wanting to know whether it's normal or not normal. So if you look at what it's saying on it says in the QQ plot, the z-scores for the observed values in the data were set in a plot on a horizontal axis. Z-scores of the expected value, assuming the data are normally distributed, are plotted on a vertical axis. If the data follow a normal distribution, then we would expect these points to lie in a straight line. If the data is non-normal, we would expect to see a distinct curve in the QQ plot. Notice that the points fall in a fairly straight line. These data appear to follow a normal distribution. You can expect little wiggles if the points in the Q plot are essentially in a line, then you can conclude that they're normal. So we're just seeing if it's normal or not normal.
Okay.
So that A would not be normal because there's a distinct curve in it.
Which one?
Plot A,
Yeah.
because it has a distinct curve. So it's not normal.
Right.
B also has a distinct curve.
Right.
C and D. Well, D is definitely normal. It has very little variation. C is kind of hard. D, E, and F all seem pretty normal.
E is not normal.
E?
Yeah.
You would say that that's a distinct curve?
Yeah, because like if you put a line straight through there, that kind of deviates a lot.
Okay. So what about C?
C, I think
Did
it
you say
is because like although it goes away like around the line, it's not like a distinct curve one direction or the other. It's kind
It's
of
like a snake.
Okay. So A, B, and E are not normal. C, D, and F are normal.
Yes.
yes.
Okay.
Again.
Did that make it easier?
Yeah.
For sure.
So that's all that it's asking, is to see whether it's normal or not.
Yeah.
We're not.
Sorry, my brain overcomplicates things. It just does that.
That's okay. That's fine.
Awesome.
That's why we're all here, right?
All right.
We can,
All right. Not normal, not normal, 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 not normal, normal. Beautiful.
I hope we
Disconnect from desktop.
Okay, before we do the quiz, I need a potty break. So,
All right.
I'll be back
Okay.
in a second.
Okay, so I have the first 6 questions.
My quiz is loading. I don't need to look at you.
Stopped. Okay, then we just have to do one more video. Do more math. True. 1, False. True. D. B. Yep. What proportion of data bullshit distortion? Wait, I have this written down. Wait, you have this written down.
Are those written down?
Yeah, it's on your prepare. Because remember, this is the one I did. Keep going. Oh, down. Okay. 68%.
Okay. I'm back.
Okay.
Okay. Look at my instructions. Okay. Starting quiz? Yes?
Yep.
Okay.
Should probably put true right there.
The total area of density curve must equal 1.
Yes.
Yes?
Yep.
Yes.
Under certain circumstances, a density curve can drop below the x-axis. False?
Yep.
The normal density curve is symmetric. Good question.
I think it's true because that's like your parent graph. So like if it was your totally perfect situation, it wouldn't be skewed at all.
See here. Okay. Fair enough. Using the following image to answer 6 and 7. Which of the following elements of the figure represents the z-score in this image? C. Which of the, right?
Yeah.
Which of the following elements of the figure represents the probability that the random variable z will be greater than 0.1? B?
Yep.
Wait, will be greater than point? Oh, yes. Sorry, I was like, what?
1.0, sorry. According to the 68, 95, 97.7 rule, the proportion of the data for a bell-shaped distribution will be within 1 standard deviation of the mean. What proportion of data? The 68, right?
Yeah.
Just one. Alright. Where did the pencil go?
Suppose random variable z
Mhm.
is included in the distribution.
Okay.
Almost done.
Okay. Suppose the random variable z has a standard normal distribution.
Alright.
Answer the question. Proportion of the values will be between 0.683.
Just a sec. Where'd it go? Yes.
Okay.
What is it called for?
Two.
Between?
Mm-hmm.
Okay.
Did you get 0.955 for that one?
Yeah.
Yes, ma'am.
And then do -3 and 3 between.
I hope this is right because this seems pretty easy.
Yeah. 997.
I can tell it's working out.
You guys.
Oh, look.
They match.
58, the 95,
Did you?
They
the
do.
997. Yeah.
Cool. That's so cool.
Awesome.
1 deviation, 2 deviation, 3 deviations.
Cool.
That's awesome.
Yeah. That makes me feel better about the answers. Okay, look carefully at your answers, last three. What do you observe?
Woo!
Oh, sorry.
Ugh.
I got excited. That's
Yikes.
for the class or something.
What's on then?
Angry.
Stupid teacher.
Alright.
I really hope that's the correct class and not our dance class. Nope. It's
The amount of protein.
Okay. Mean is really all I care about.
This is giving me terms. Population.
Is less than 0.6.
Okay, what proportion of the population have a protein requirement that is less than 0.6 kilograms?
All right. Z-score.
I got cookies.
Okay.
The cookies.
Whatever the saying is. Can't remember. Now I just want to call it $1, even though it's not $1. Okay. So it equals a less than 0.6
Yeah.
minus 0.66 over 0.07. Okay. 0.6 minus 0.66 divided by 0.07. It sounds like parrots, not. What was the question?
Below 0.6. That's 0.8.
But this is the Z-score.
Oh.
I think. Possibly. Okay. How about you? I don't need you anymore.
Right, because the mean is 0.66.
Okay.
So,
Because you want to just find the Z-score first, and that would be 0.6, which is what we're trying to figure out, minus 0.66, which is the mean, over 0.07. And that equals negative 0.857.
So 0.6 minus 0.66 divided by
0.07.
0.07.
Yeah. That's gross.
That's good.
Look.
Negative 0.857.
Yeah, so we would plug that into the probability app, right?
Yeah. In the Z-score,
Then find everything below that.
0.857. 0.196.
Yeah. Beautiful.
Okay, now we're just finding more than 0.6.
Oh, I like this. 1 minus answer. That was not going to work. We're going to go like this.
0.804?
Yep.
Less than, now you have to do 0.7, less than 0.7.
Okay, so 0.7 minus 0.66.
Point 571.
Oops.
What's the question?
What?
Less than.
579. My stomach moving. Everything less than, right?
Yeah.
Yes, less than.
Alright. What'd you get?
0.76716.
Yep.
Woohoo!
Yeah?
Yeah.
Yep.
0.716. Okay.
And the area between.
So now you have to find it between again. Remember?
I know. The last time he did it wrong in his homework.
Well, we just have to do it the way that he says to do it on the homework.
What if he did it right on here, though? Let's just do it right. And then we can ask
Argue.
him. Yeah, and then he can change it for us, because we did it right. Yeah?
Alright. So, you plug in z-scores, right? Alright.
Aren't we just subtracting the areas? The 0.804 minus the 0.716?
I thought you had to subtract the z-scores and put that in and find the area between.
No, you take the z-scores and find the area. Hold on.
Yes.
Less than. I don't know.
Take the z-score, find the area. Okay. So now to answer the question by finding the area under the normal density curve to the left, z is everything to the left.
Everything to the left of what?
That's what it says. Now in the homework, in the preparation, we now answer the question by finding the area under the normal density curve to the left of z. So it's everything to the left of z. Sorry, guys.
It's alright.
We're almost finished.
You find the z-scores to the left.
Small area. From the larger.
Okay. We'll find the area between. is to the left of the Z.
Left of the bigger one. So that's right? And then to the left of this one.
To the left of both? It doesn't make any sense.
Yes, that's what it says. To the left of both.
All right.
Okay. So you would just take this number minus this number?
Yeah.
Weird.
I have 0.088. Is that what you got?
Which one?
This one minus the...
You just take the answer for 14 and subtract it from 15.
Are you sure? Oh yeah, that's right. Yeah. Mm-hmm.
Wait, what?
Because more than this, 6.6 would be to the left.
That's to the right.
To the right. Right. So no, it would be 0.7
Oh, I'm sorry. Yeah, you're right. Hold on.
minus 0.196, right?
Hold on. So,
152. It doesn't have 3 decimals.
what proportion of the population have protein that is more than? I think I plugged that number in wrong. Point.
That just doesn't seem right. But that would be inconsistent with the homework.
Whatever. I just want to check it out.
I think the answer for 14 is actually 196.
Why?
Because it's saying more than.
Yeah, so what we did was... Where'd it go?
You find the z, which is negative 0.85. Right? You plug it in.
Yeah. So you find everything more than that,
Mm-hmm.
which is on the other side of the graph.
More than the negative. Okay, yeah.
So we're right.
Well, it's the same answer if you do everything to the left or everything to the right. Oh, no, hold on. 0.857. Everything to the left. So is it...
Because our z-score was the negative,
Yeah.
so that's where we base it off of.
So we're subtracting 0.716 minus 0.196.
Yeah.
Yes.
0.52,
Yeah.
0.520, because it wants 3 decimal places.
I guess. 0.520. Okay. That's what you guys got?
All right.
All right.
Submit.
Let's submit.
Oh, look at that! Oh, we are awesome!
Neat. What did we miss? Okay, that was... So,
Wait, did you miss one?
I did! I put false when I meant to put true.
Oh, no.
Otherwise, we would have gotten 100%. Or I would have, yeah. You guys. Okay, cool. Whew. Oh my gosh.
That makes me happy.
That's good. I feel a little more confident about this.
You're almost there, but you haven't done the homework.
89.
You haven't done the homework.
I know.
So you're going to get it. It's going to be fine.
Okay.
Wait, where'd you go?
Oh, she's on you.
Okay.
Where'd you go?
Sorry, that's like half my head. Alright, so we just need to submit this now and we're done?
Yeah.
Done with the group meeting at least.
Yeah.
All right. I'm going to stop this broadcast and we'll be done with this.
Alright, you guys are awesome.
All right.
Whew, we did it.